Preface to the Psychic Life of Micro-Organisms by Alfred Binet. This is a LibriVox recording. All LibriVox recordings are public domain. For more information or volunteer, please visit LibriVox.org. Recorded by Leon Harvey. The Psychic Life of Micro-Organisms. A Study in Experimental Psychology by Alfred Binet. Translation copyright by the Open Court Publishing Corporation, Chicago, Illinois, 1888. Preface to the American edition. I have endeavored, in the following essay upon microorganisms, to show that psychological phenomena begin among the very lowest classes of beings. They are met with in every form of life, from the simplest cellule to the most complicated organism. It is they that are the essential phenomena of life, inherent in all protoplasm. We admit, accordingly, the existence of a vitalism, that is to say, of an aggregate of properties which properly pertain to living matter and which are never found in inanimate substances. Among these properties of life we classify psychological phenomena. Vitalism, it is unnecessary to say, has nothing in common with the doctrine upheld by the school of Montpellier. The principle here involved has nothing to do with properties and forces that are superadded to living matter. It concerns the properties that are inherent in it, the properties that characterize life. The modern opponents of vitalism seek to confute the theory by attempting to explain all phenomena of life from physico-chemical forces. They maintain that according as physiology advances, the tendency is to relegate all phenomena nominally physiological into the domain of physics and chemistry, and that it would only be a question of time if as yet they had not succeeded in demonstrating that every vital process is founded upon mechanical phenomena. In a recent treatise upon vitalism and mechanism, Mr. Bunge, professor of physiology at Basel, has shown that the history of physiology disproves these hypotheses. The more closely the phenomena of life are scrutinized, the more carefully they are studied in their various aspects, the more certain does the conclusion become that the processes attributed to physico-chemical forces in reality obey much more complicated laws. To illustrate, it was at one time conceded that the phenomena of resorption and nutrition were explainable by diffusion and endosmosis. Vouteros, upon his discovery of endosmosis, imagined even that he had discovered the principle of life. At the present time we know that the walls of the intestines do not in any wise act like the inanimate membrane used in experiments in endosmosis. They are covered with epithelial cells, each of which is an organism endowed with a complex of properties. The protoplasm of these cells lays hold of food by an act of prehension, exactly as the ciliate infusoria and other unicellular organisms do that lead an independent life. In the intestines of cold-blooded animals, the cells emit prolongations which seize the minute drops of fatty matter, and carrying them into the protoplasm of the cell, convey them thence into the chylofactive ducts. There is still another mode of absorption of fatty matters, met with among cold-blooded as well as warm-blooded animals. The lymphatic cells pass out from the adenoid tissue which contains them, so that upon arriving at the surface of the intestines, they seize the particles of fatty matter there present, and laden with their prey, make their way back to the lymphatics. Accordingly, the faculty of seizing food and by exercising a choice among foods of different kinds, a property essentially psychological, appertains to the anatomical elements of the tissues, just as it does to all unicellular beings, in the manner shown in our treatise. It is plainly impossible to explain these facts by the introduction of physico-chemical forces. They are the essential phenomena of life and are the exclusive appurtenants of living protoplasm. If the existence of the psychological phenomena in lower organisms is denied, it will be necessary to assume that these phenomena can be superadded in the course of evolution, in proportion as an organism grows more perfect and complex. Nothing could be more inconsistent with the teachings of general physiology, which shows us that all the vital phenomena are previously present in non-differentiating cells. Furthermore, it is interesting to note to what conclusion the admission would lead, as Romans apparently does admit, that psychological properties are wanting in lower class beings and that they enter at different stages of zoological development. Romans has minutely particularized on a large chart the development of the intellectual powers in quite an arbitrary manner. According to his scheme, only protoplasmic movements and the property of excitability are present in the lower class organisms. Memory begins first with the echinoderms, the primary instincts with the larvae of insects and the annelids, the secondary instincts with insects and spiders. Reason, finally, commences with the higher crustaceans. I do not hesitate to say that all this laborious classification is artificial in the extreme and perfectly anomalogous. All writers that have devoted themselves with any pretension to special investigation to the study of unicellular organisms have attributed to these beings most of the psychological properties which M. Romanes reserves for this or that higher class animal. This is the opinion of Gruber, of Verworn, of Mobius, of Balbiani, and of many other naturalists. Mobius recognizes that psychological life begins with living protoplasm, and he considers it to be the highest aim of zoology, to demonstrate the psychical unity of all animals. We could, if it were necessary, take every single one of the psychical faculties which M. Romanes reserves for animals more or less advanced on the zoological scale, and show that the greater part of these faculties belong equally to microorganisms. But we must not unnecessarily extend the discussion of this introduction. We shall accordingly limit ourselves to a few illustrations. M. Romanes in his zoological scale assigns the first manifestations of surprise and fear to the larvae of insects and to the annelids. We must reply upon this point, and there is not a single ciliate infusory that cannot be frightened, and that does not manifest its fear by a rapid flight through the liquid of the preparation. If a drop of acetic acid be introduced beneath the glass slide, in a preparation containing quantities of infusoria, the latter will at once be seen to flee from all directions like a flock of frightened sheep. Memory, according to M. Romanes, first begins with the echinoderms. Now Mobius, upon the occasion of a treatise upon the Folisulina ampulla, a ciliated infusory presenting complicated and interesting movements, probably remarks that every time an animal repeats the same action under influence of the same excitations, the fact proves that the animal is possessed of memory. In fact, memory is one of the most elementary of psychological facts. Lastly, the primary instincts, according to M. Romanes, begin first with the larvae of insects and with annelids. We give, in contradiction to this statement, the recent observations of Verworn, which reveal the existence of curious instincts among the rhizopods. The Diffugia ursulata, which inhabits a shell formed of particles of sand, emits long pseudopodia which search at the bottom of the water for the materials necessary to construct a new case for the filial organism to which it gives birth by division. The pseudopod, after having touched a particle of sand, contracts, and the grain of sand adhering to the pseudopod is seen to pass into the body of the animal. Verworn, instead of grains of sand, placed small fragments of corded glass about the animal. Some time afterwards, he noticed a heap of these fragments on the bottom of the shell. He then saw a bunch of protoplasm tissue from the shell representing the new diffugia produced by division. Thereupon, the materials collected by the mother organism, the fragments of colored glass, came forth from the shell and enveloped the body of the new individual in a sheath similar to that encasing the mother. These fragments of glass, loosely interjoined at first, were now cemented together by a substance secreted by the body of the animal. Two facts to be remarked in this observation. First, the act whereby the diffugia collects the materials for providing the young individual with a case is an act of prepidation, to an end not present, but remote. This act, therefore, has all the marks of an instinct. Further, the instinct of the diffugia exhibits great precision, for the diffugia not only knows how to distinguish, at the bottom of the water, the materials available for its purpose, but it takes only the quantity of material necessary to enable the young individual to acquire a well-built case. There is never an excess. It is interesting to note that the diffugia does not act differently from animals possessing more highly complicated organizations and endowed with differentiated nervous systems, as for instance the larvae of pharangids, which form their sheaths from shells, grains of sand, or minute slivers. We should not regard it as strange, perhaps, to find so complete a psychology in the history of lower organisms, where we call to mind that, agreeably to the ideas of evolution now accepted, a higher animal is nothing more than a colony of protozoans. Every one of the cells composing such an animal has retained its primitive properties, giving them a high degree of perfection by division of labor and by selection. The epithelial cells that secrete the nails and the hair are organisms perfected with reference to the secretion of protective parts. Similarly, the cells of the brain are organisms that have been perfected with reference to psychical attributes. Paris, November 20, 1888. Alfred Binet. End of preface. Introductory. The Psychic Life of Microorganisms. The study of microscopic organisms has hitherto been somewhat neglected by students of comparative psychology. Naturalists who have devoted their attention to the study of these beings have collected a great number of interesting facts concerning their psychic life. But these facts have not yet been critically examined and collated. They are scattered in reports and publications of all kinds, where the psychologist never dreams of looking for them. We shall endeavour to make him acquainted with a part of this wealth. Under the name microorganism are included all those beings which by reason of their extreme smallness and simplicity of structure represent the lowest stages of animal or vegetable life. They constitute the very simplest forms of living matter and consist of a single cell. Some inhabit fresh and salt waters, serving as food for a great many other organisms, or contributing by means of their calcareous or siliceous skeletons to the formation of continents. Others live as parasites in the organs of animals and plants, and induce more or less serious disorders in the constitutions of the organisms they have penetrated. Others again, acting like ferments, produce important chemical modifications in organic matter in the course of decomposition. A great number of classifications for the methodical distribution of these beings has been proposed, but not one of them is altogether satisfactory, and that stands to reason. If a natural classification is always a complex piece of work in the case of the higher animals, which differ from each other in important features and between which a comparison can be instituted, the difficulty attending the classification of simple organisms which present only the slightest differentiations is still more difficult. The principal division made is that which divides them into animal microorganisms, or protozoans, and vegetable microorganisms, or microphytes. The line of demarcation between these two kingdoms is far from being well defined. There are a great number of microorganisms and cetacea which botanists usually place in the vegetable kingdom, but which zoologists prefer to classify as belonging to the animal kingdom. We give below a list of the most important groups of animal microorganisms: Infusoria, ciliates, suctoria, suckers, Mastidophores, flagellates, choanoflagellates, dinoflagellates, cystoflagellates, sarcodines, rhizopods, helizoa, radiolarians, sporozoa, Gregarinidae, Coccidia, Sarcosporidia, Mixosporidia, Microsporidia. We propose now to study the psychic life of these lower organisms, or, to speak in more general terms, their life of relation. It is well known that the expression the life of relation comprehends essentially two distinct ideas. First, the action of the external world felt by the organism, or sensibility. Secondly, the reaction of the organism on the external world, or movement. It is customary to apply to the union of these two properties the name irritability, which expresses the reaction of the microorganism upon exterior forces. It is therefore held, and with reason, that every living cell is irritable, that is to say, that it possesses the property of responding to movements, to the excitations which it suffers. In admitting then that irritability is the foundation of the life of relation, and consequently also the foundation of psychology, we must nevertheless guard against comparing the autonomous cell of microorganisms to a single irritable cell. Although the body of these small beings may be equivalent to a simple cell, it would be an error to believe that their life of relation consists in a motor reaction consequent upon exterior irritation. At the close of our investigations into the psychology of proto-organisms, we shall see that, in these inferior beings which represent the simplest forms of life, we find manifestations of an intelligence which greatly transcends the phenomena of cellular irritability. Thus, even on the very lowest rounds of the ladder of life, psychic manifestations are very much more complex than is usually believed, and the conception of cellular psychology, which some very recent authors have formed, seems to be a very crude analysis of the most delicate of phenomena. In the great majority of pluricellular animals, the life relation is exhibited in a nervous system and in a muscular system. In microorganisms, the same cannot be said to be the case. The greater part possesses neither a central nervous system nor organs of sense. Some even lack organs of locomotion. The functions of the life relation are performed by the entire mass of the body. Many of the protista, for example, have not a trace of an anatomically differentiated visual organ. It is the entire protoplasm of the elementary organism that is excitable by light, as it is also by heat or by electricity. In other microorganisms, somewhat higher in the scale, a beginning of differentiation may be seen to make its appearance, giving birth either to some organs of sense or to some organ of locomotion. We shall give a general description of these organs. The study of this first move in the work of differentiation is of great interest to comparative anatomy and physiology. No less interesting it is to psychology. Besides dwelling on these preliminaries of our work, we shall have occasion to note new and interesting facts. End of introductory and preface. End of section 0.